Hello, this is Henrik Beshman. I'm a software developer. My proprietorship is internetcommons.ca. You can see my LinkedIn profile at the URL listed there. The purpose of this screencast is to present a design challenge to software developers. Just an interesting challenge that I encountered while reviewing Eric Evans' book, Domain Driven Design. And I think it's an interesting area to pursue. So just a bit of background before I specify the particular challenge. Software design is the end product of a process involving the review of a problem space, ideally abstract modeling, which leads to an assembly of abstracted components, including behavioral assertions, the key behavioral assertions and restrictions placed on their interaction, and finally that leads to a design which is implementation specifications and a concrete plan. So the benefit of putting effort into this, one of the many benefits, is that design is cheaper than building or coding by a wide margin, obviously because it's done on paper, as it were, and is more abstract than implementations. Can be easily changed. The rule of thumb I've used for quite a while. I've been at this since 1981, so 34 years as of recording this screencast, is that development is 10 times more expensive to change than design, and deployment is 10 times more expensive to change than development. I don't know, it's a rule of thumb. It can vary, obviously, but it was taken, I believe, originally from a study that was done quite a long time ago by IBM. So based on that, after a lot of experience, I found that it's worthwhile to accept this as the first rule of programming. Get your darned hands off the keyboard and think about the problem that you're trying to resolve before actually diving in. Obviously, developers' inclination typically is to jump on the keyboard and start having fun. Having said all that, we have learned collectively over the last decades that design is only effective up to a point. Agile development has shown us, although it's quite hard to implement, surprisingly hard in some ways, nonetheless it's shown us that some things cannot be anticipated, a lot cannot be anticipated in the development of software, and in fact the best way of improving a design is to embrace discoveries that are made along the way, allow for an open development process and improvement of the design in a cyclical, iterative fashion as you go along. Easy enough to read up on some of those principles by looking up the Agile Manifesto and related readings. We've also learned that design, really related to that, is an iterative process, is a living process. So documents are only useful as long as they're relevant, and sometimes they drop away. But design is aided by iteration and experimentation. And a critical point in terms of what I'm talking about here, it's also supported by refactoring. In other words, having a look at the implementation and code of your design, seeing what's discovered there, seeing how it functions, conceiving of improvements in the structure and implementation of that code, and feeding that back into the design process. We're blessed with many mature tools for design. Two of the key ones that are close to the implementation level are design patterns. Again, easy enough to look those up. There are many of them. I think they're useful not only in terms of reviewing external design patterns that have been developed by others, but by using the same approach to developing our own design patterns as we encounter general solutions to common problems, which is what they're for. It does impose, structure and discipline. Also, the unified modeling language, which I think by and large has been found to be useful for sketching ideas and communication, not so much for a comprehensive and highly detailed view of an implementation, but nonetheless an excellent tool. In spite of all that learning, developers being people with personal interests do tend quite often to fall into the prototyping trap. Let's just try this out, and only to find that as a general rule, there's no such thing as a short-term solution. Short-term implementations tend to be kept and then refactored and built upon. And if those short-term solutions are developed prematurely, then it can lead to brittle solutions, something called the ball of mud, which again can be Googled, but basically rushing into prototyping or development leads to problems. So worth avoiding. So leveraging design requires discipline, skill, experience, collaboration. All those things should be obvious. One of the key contributors to the literature on design is Eric Evans, who's written this book published in 2003, Domain-Driven Design, which focuses on creation of a distilled design for a core domain of the problem space. There's a broad context to that. I'm not going to get into that very much, but certainly well worth looking at and reading. As I mentioned earlier, one of the things that really jumped out at me in reviewing his approach to design is that a coherent design really covers all aspects of software development. As I mentioned, beginning with a focus on the domain problem through modeling process, certainly architecture, which is separation of concerns for a project, planning, including the iterative design process, but also including, and this really jumped out at me, the actual implementation or the coding. So his vision of design process really reaches right into the actual source code files, how they're structured, how they're organized, the terminology that's used, and so forth. I thought that was very interesting, and so the purpose of this screencast is to focus on that idea and present it with a view to really probably getting some feedback and hopefully generating a bit more discussion about it. So Evans proposes a number of basic tools to do this, and again we're talking about pushing the formal design into the coding files themselves. Certainly begin with the general approaches to domain-driven design, which is model-driven development, what he calls the ubiquitous language, which is a common terminology. So one way to approach that is to create a glossary really for a project and share that among everyone involved, including what Evans calls the domain experts, or read the client, but really everyone involved, the project manager, the designers, the coders, the testers, and so forth. And then again include binding the model and the implementation together, which is a two-way street. So conceive of the implementation when you're working on the design, and when you're working on the implementation, really be sure that you reflect the design in very specific ways in the implementation of the code, again involving both the structure of how that code is maintained and the actual terms used in the functions and whatnot within the code itself. The reward of all this is that you end up with a distilled design, a cleared shared language, the smallest possible implementation thanks to the clarity, and of course what we all strive for, better outcomes in terms of maintainability, scalability, and extensibility. So here's the beginning of the challenge, to sort of shift the mindset of the developer, such that coding or building is not just an independent implementation of a received design. Very often developers take a design and then shift their mind away to an independent process of organizing a technical design for themselves that may not relate thoroughly to the design itself, may only involve, typically an API. Evan's challenge is to go further than that. By looking at the design for specifics of the implementation. So another way to look at that is that coding actually is design. It's another aspect of design. I think most developers that I've known, including myself, think of coding as being separate from design. Of course, with experience, we do technical design in our minds, but often don't really take that direct view in terms of linking our coding efforts to the design, in the sense of conceiving of the code as an extension of the design, and really being an aspect of the design as a whole. So there's a mind shift there. Very specifically, the code should support a paradigm. That's easy nowadays. Most implementation languages are object-oriented, and that is highly compatible with various design methodologies and approaches. Code, class, and component structures should reflect the design structures, so that when you're comparing the sort of formal design and some of the design sketches and some of the design documents and the actual code itself, you should really see a similarity among those. So, for example, the library of source code should ideally be organized in such a way that compares fairly easily to the design structures themselves. So, I don't know, database access, would be in one area and shown and compared in terminology and structure to the database aspects, or really the repository aspects of the design, and so on. And the names used in source code should reflect the names used in the design, so that a coherence between the two is enforced, and a familiarity is presented when looking to the source code after reviewing and conceiving of the design itself. Here's the challenge that really focused my attention and honestly surprised me, but I think it's worth pursuing, because I think it does insert an additional level of discipline and coherence, and provide an opportunity to get more benefit from the design process. So the challenge is to actually, from time to time, show the source code to what Evans calls the domain experts, which in most of our terms is the client, and the client should be able to make sense of the source code with a little help, by virtue of the fact that the client or the domain expert has been involved in the design process and is therefore familiar in detail with the components of the design, and given that the source code is organized to reflect that, then the client should be able to make sense of the source code. And after all, most source code, if it's well written, is of necessity extremely logical, and the processes reflected in that logic should be familiar, at least in kind of a general level, to the domain experts. I think it's kind of an amazing challenge. I think it is a challenge which, if pursued, can, as I say, lead to both far better code and better discipline and really better outcomes, and probably for the domain experts or the clients lead to an increase in confidence and assurance that the project is doing what it should. Having said all that, domain-driven design, which is what Evans really talks about, as he points out himself, both in the book and in some talks that he's given fairly recently, is not always appropriate. It is most appropriate for large, complex applications, which, by appropriate, I mean one gets the benefits and leverage. When the greatest benefits and leverage when applying this method to complex projects, not so much for small projects. So for the smaller projects, different approaches might be appropriate. In particular, very straightforward database applications, instead of taking this sort of broader domain-driven design aspect, might be more to the point to simply do a semantic analysis of the database application. That often works for sort of departmental level applications and is very straightforward. And obviously simple applications, particularly when they're on tight budgets, you know, if there isn't going to be too much demand on them in terms of scaling them up and modifying them later, you know, why not just go for it, put your hands on the keyboard and do it. Personally, I think that's a very limited space, but even so, you know, there are applications of that type, and that would be appropriate. In any case, I think it is a good discipline to push design into code. That is, always think of coding as a design exercise by thinking about the coherence and interaction, separation of concerns, independence of individual modules, reliability of assertions, and all that stuff. So basic design principles should be applied. Simplicity, elegance, balance, and completeness are the terms I use. Elegance meaning a combination of simplicity and power or leverage. Wherever possible, apply and find find and apply design patterns or invent them yourself. Again, it's an approach to discipline. Apply decoupling and clear module interfaces, obviously, and clear terminology. So the bottom line for developers, I think, in pursuing this approach is that design effort yields dividends. Integrity, clarity, great communication, obviously. Productivity, because a carefully conceived and designed implementation requires fewer iterations. Iterations are always good. Refactoring is good. Endless iterations and endless refactoring as a result of essentially sloppiness is bad. It also provides for stability. Certainly for well-designed applications that I've seen and been involved with, you know, the typical pattern is that bugs appear after an application is first released, just because you get users doing things in the application that hadn't been tried or hadn't been conceived of by testers, but very quickly in a well-designed application drop off, and then fairly quickly the application stabilizes to the point where, you know, really there's no issues come up for a very long time, or very rarely, you know, on a yearly basis or something like that. So lots of benefits to all that. So I hope you find this somewhat interesting. By all means, contact me with comments or questions, henrik@internetcommons.ca. Have a good day.